Hello everyone, today let's solve the problem number 19. Remove nth node from the end of the list. What the question states here? So we have been given the head of the linked list. You can clearly see here in the example one. We have been given the head of the linked list. Remove the nth node from the end of the list. So we have to remove the nth node, means they have given n here. N equals 2, right? This is 0 index. Sorry, just give me a second here. So here this is 0 indexed, and when I say it is 0 indexed, we have C here. Just give me a second here in this case. This is 0, 1, 2, 3, 4. So we have been asked to remove the nth node from the end of the list. Nth node from the end of the list. And from the end of the list means we have to start from 5, right? And we have been given n equals 2. This n equals 1, n equals 2, n equals 3, n equals 4, n equals 5. So we have been asked to remove the nth node from the end of the list. So just keep this in mind. So n equals 1, 2, 3, 4, 5 here, right? So this one, 1, n equals 2 they have given, means we have to remove 4 in this case. So when we remove 4, we get 1, 2, 3, 5. 1, 2, 3 and 5. So that's what we need to return in the output, right? That's what we need to return in the form of output, 1, 2, 3, 5. So that's what they have given in the question, right? So let's come to the second example here. We have been given, just give me a second, 1 and n equals 1, right? So we have only one element. So suppose we will consider this one itself. When we remove this one, we have to return the empty array, right? So this is fine. Let's come to the third example. We have been given two nodes here, 1 and 2. N equals 1 they have given here in this case. So this one itself, the last element itself, we need to remove. We have to remove, basically we need to remove the nth node from the end, right? So second one, this one 2 we will remove. N equals 1 they have given, first element from the end. We will remove this one, only 1 will remain. So that one we need to this one return in the form of output in the array, right? So 1. So here I hope the question is completely clear. What we need to do is completely clear as well. Easy one, right? So first what we'll do, let's discuss the approach, followed by the edge cases one by one, and then finally write the code and discuss the complexities of the code that we have written. First, let's discuss the approach first. So here, first thing that we need to note down here is we will be going with the 2 pointers or the 2-pointer approach, right? So I have considered the first example that they have given in the question so that it will be easier to understand the approach, right? So we have already discussed this one. 1, 2, 3, 4, 5 we have been given. So n equals 2 here. So we need to remove the n from n, right? This becomes 1, this becomes 2, 3, 4, 5, n. So we have to remove 4 here in this case, this one, right? So when we remove 4, we get 1, 2, 3 and 5. So that's what we need to return in the form of output. We know this one, right? So let's move on with the step-by-step execution part here. So first thing here is we will initialize the dummy node, right? So we'll initialize the dummy node. So this 0 is dummy node. 1, 2, 3, 4, 5 we already have this one in the list, right? So we will initialize the dummy node 0 here in this case. So this will make the traversal easier, right? So that is the reason we will be making use of the dummy node. You'll come to know further. So let's move on with the second step here. We will be making use of 2 pointers here. One is fast and another one is slow, right? So fast and slow. We'll be making use of 2 pointers, fast and slow here. We will move fast n plus 1 steps ahead, right? So we will move fast n plus 1 steps ahead, right? So here in this case, when I say n plus 1, when this is at this one, what do you call it? When slow is at 2, this one fast will be at 3 in this case, right? So here, when slow is at 2, fast will be at and plus this one 3. So now fast moves to 3 here in this case. Fast moves to, currently both the pointers will be at 1 itself. Slow moves to 2 and fast will move to 3 because fast moves n plus 1 steps ahead. Slow dot next, fast dot next, right? So I hope this is clear. Let's move on with the third step here. Just give me a second. Let's move on with the third step here. We will move both the pointers one step at a time until fast reaches the end, right? So then after the second step, we will move both the pointers one step at a time, one steps at a time, until fast reaches the end, right? Now slow is before the target node 3. Slow is before the target node 3. Once we will remove the nth node. Next step, we will remove the nth node. Nothing but slow dot next is here 4 is skipped here in this case. Slow dot next. This one 4 is skipped. When this is at 5 basically, this one slow dot next will be this one in this case 4, right? So we will be skipping this one, means we will be deleting this one, right? When we delete this one, we get 1 2 3 and 5. So that's what we will remove the nth node. Nothing but slow dot next 4 is skipped in this case. Easy to understand, right? We will return the updated list. Updated list will be quite obviously 1 2 3 and 5. 4 is skipped, right? So I hope this is clear, easy to understand, right? So this will be the final output. We got output as 1 2 3 5, which is equivalent to the output that they have given for the first question. First example in the question. So approach works absolutely correct in this case, right? Now we are completely familiar with the approach. As we are familiar with the approach, let's move on with the edge cases. So the first edge case here is for the single node list. So we have only one node here. N equals 1 we have been given. So when we remove this one, we will get the empty list or the empty array here, right? So this one, we will return the empty array in this case, right? So only one node we are having. We will be removing it, which leaves an empty list. So let's move on with the second edge case here, removing head. When I say removing head, we have been given two elements here, 1 2, and n equals 2 we have been given. So we are removing from the end, right? This becomes 1 and this becomes 2. We will remove this one 1 and output remains this one 2. So only node 2 remains. That one itself we need to return in the form of output. This is fine. 2 remains in the list. So let's move on with the third edge case here, last node removal. So we have been given 3 nodes here, 1 2 3, n equals 1. So from the end we are removing, we will remove this one, right? This will be 1, this will be 2, this will be 3. We will remove the element 3. So when we remove the element 3, it becomes 1 comma 2. That's what we need to return in the form of output, right? So last node removal. First edge case is for the single node list, second edge case is for removing head, third edge case is for the last node removal. These are the three edge cases that we need to keep in mind, right? Now we are completely familiar with the approach as well as edge cases. As we are familiar with the approach and edge cases, so it would be easier to write the code. Let's start writing the first step here is we will create the dummy node before the head. We saw this one in the approach. Dummy node 0 we had created, right? So I'll just go with here list node. Let me make use of the variable dummy here. So this one will just give here new list node of 0, right? So I hope this is clear. We are creating the dummy node before the head, nothing but 0 in this case. So next step, I'll just assign dummy dot next to head. So the next element is head, right? So we'll assign the dummy dot next to head. So next step, we are going with the slow and fast pointers, 2 pointers, right? Slow and fast. Let's initialize that one as well. I'll just go with list node fast equals this one. Let me give dummy here. In this case, slow also, let me initialize this one to dummy. This is fine. So the next step here is we have to move the fast pointers n plus 1 steps, right? Before moving both pointers until fast reaches the null. The second step was, if you remember, we have to move the fast pointer n plus 1 steps. Let's go with the iteration quickly here. Int I equals 0, I less than or equal to n. Let's increment the I here. Fast will be here in this case, fast dot next. This is fine. After this step, after moving the fast pointers n plus 1 steps, we have to move both the pointers until the fast reaches null, right? So I'll just make use of while condition. Fast shouldn't be equal to null at any cost. So I'll just make use of while loop here. And fast not equal to null in this case. So here fast equals fast dot next. This is fine. And slow equals here. Let me initialize this one to slow dot next. This is fine. So the next step here is we have to remove the nth node from the end. So we know that one. So how can we implement that one in the form of code? I can just give here slow dot next. This one equals slow dot next dot next. So this is how we ignored or we ignored 5. We skipped 4. Right? So we saw this one in the approach. This is how we skipped 4 basically in the first example. Right? So output that we got was finally 1, 2, 3, 5. We saw this one during the approach. So I'll just come to the next step here. After removing the nth node from the end, we will return the new head, nothing but dummy dot next. So we have to ignore the dummy element, right? So I'll just give here, we have to return the new head. I'll just give here dummy dot next in this case. So this is it for the, let me hit the format. Let me format this one and hit the run button. So you can clearly see the sample test cases are getting passed, right? Let me quickly hit the submit button. So here you can clearly see all the test cases are getting passed. Means the code works absolutely correct in this case, right? So let's quickly discuss the complexities for the code that we have written. So the approach that we went with here is 2-pointer approach, right? We have made use of fast and slow pointers, right? So here you can clearly see 2 pointers, fast and slow. We have made use of fast and slow pointers. This is fine. So the overall time complexity would be here in this case. Overall time complexity would be, you can just consider here SZ or SZ. So traversing the list once, we are traversing the list once. You can clearly see we are traversing the list once, means fast moves n plus 1 steps, then both move together, fast and slow. Here in this case, fast moves one step, n plus 1 steps, and then here while loop, here within this while loop, fast and slow pointers both move together, right? So we have discussed this one in the approach. So overall time complexity would be big O of SZ. So what will be the space complexity here? The overall space complexity would be in this case big O of 1. So why it is big O of 1 here? Because we are making use of the constant extra space, nothing but we are making use of only dummy, fast and slow pointers, right? So we are making only we are making use of dummy, fast and slow pointers only, which requires constant extra space. No need of additional extra space here, right? So overall space complexity would be big of 1 in this case. So the time complexity is big of SZ, and the space complexity is big of 1 in this case, right? So I hope the complexities are clear, and I hope whatever the code that we have written is completely clear as well, right? For now, this is it. Thanks for watching, guys.